Okay. So if cos of theta is 3/8 and theta is not in quadrant 1, find sine theta and tan theta. Now, this may seem surprising, but one of the key strategies in the trigonometry unit is drawing a triangle. So in a question like this, you know SOHCAHTOA, so you know how to draw triangles. You know that cosine is the adjacent side over hypotenuse in a triangle. But where is this triangle? We draw an angle in standard position. It's not in quadrant 1. What quadrant would it be in? Well, according to the cast rule, if cosine is positive, it's either in quadrant 1 or quadrant 4. And since it's not in quadrant 1, you know that the angle has to be in quadrant 4. Angles in standard position go like this, but the triangle you're going to make is going to use the reference angle. So you need to make your triangle back to the nearest x-axis and label your reference angle. Once you have your reference angle labeled, you can now say, I know in this triangle the adjacent side would be 3, the hypotenuse would be 8. Can you solve for the other side? Absolutely. You're going to get really good at a squared plus b squared equals c squared. You're going to do it in mental math. You're just going to look at this and say square root of, close, careful, this is the hypotenuse is here, so it shouldn't be more than 64. You're going to do 64 minus 9, square root of 55. And now that you have your triangle, it's not going to be hard to write out what is sine of theta. Well, look at your triangle. There's our reference angle. Sine of our reference angle would be root 55 over 8. So sine of our actual angle will also be root 55 over 8. But because it's in quadrant 4, sine has to be negative. And when we go tan of theta, opposite over the adjacent side. And because tan is in quadrant 4, it'll be negative as well. So we're going to use our cast rule a lot. We're going to draw triangles a lot. We're going to use our reference angle a lot. And then we can figure out the other trig ratios. Second question. Is this point on our unit circle? Well, initially, when you think about your unit circle that you're memorizing and thinking about the points that are on there, your initial answer might be no, it's not, because it's not one of the ones that are listed. But does it make sense that there are a ton of points that are on the circle but aren't listed? Like there's a point here, and a point here, and here, and here, and here. A whole bunch more points that aren't on this circle. Could it possibly be that this is one of them? It could be. How do we find out? Sine squared theta plus cos squared theta has to equal 1. If this point is on the unit circle, then this is cos of the angle, and this is sine of the angle. If we square them, and it equals 1, it's on the unit circle. If we don't square them, or if we square them and it doesn't equal 1, it's not on the unit circle. Because this big idea of sine squared theta plus cos squared theta equals 1 comes from the equation of the circle. Here, I'll put unit circle, where it's x squared plus y squared equals 1. So if we square root 6 over 3, and we square root 3 over 3, How do you square a fraction? Multiply by itself. Can you see that this root 6 times root 6 will be 6? And 3 times 3 would be 9. Plus root 3 times root 3 would be 3. And 3 times 3 would be 9. And we get 9 over 9. Does that equal 1? Yes. You ready for your brains to just explode just a little bit? Just a little bit? Okay, we're going to start off I'm going to ask you which number is bigger? 1 or 0.9 repeated? Okay. Which number is bigger? Like larger? Length? Value? Which one's bigger? Okay? They're actually the same number. Okay? Now I'm going to prove to you that they're the same number. This is where your brain is going to get blown a little bit. First of all, does anybody know what I'm going to start with explanations that aren't that good, and I'm going to move on to explanations that seem more realistic. Okay? So I'm going to start off with this explanation. Does anybody know what 1/9 is as a decimal? 0.1 repeated. Does anyone know what 2/9 is as a decimal? 0.2 repeated. 3/9? 0.3 repeated. 4/9, 0.4 repeated. 5/9, 0.5 repeated. 6/9, 0.6 repeated. 7/9, 0.7 repeated. 8/9, 0.8 repeated. What's 9/9? 0.9 repeated. It fits the same pattern, right? But it seems a little bit wrong. It seems like that's my worst explanation. But if we took the 3/9, which is the same as 1/3, would you agree that that is 0.3 repeated? And if I took another 1/3, and I took another 1/3, now if you add up 1/3 plus 1/3 plus 1/3, you get 1. But if I add up the right side, I never have to carry. It always works out that there's going to be a 9. No number ever carries over. It will be 0.9 repeated. So that one feels like a little bit better of an explanation. Okay? And the last explanation. We're going to say x is 0.9 repeated. Okay? If x is 0.9 repeated and you multiplied something by 10, it would just move the decimal place over. Would you agree then that 10 x's would be 9.9 repeated? Then on this side, I'm going to subtract 1x, which means on this side, I'm going to subtract 0.9 repeated. Can you see that 9.9 repeated minus 0.9 repeated, all you would be left with on this side is 9. And on this side, 10x minus x would leave me with 9x. Divide both sides by 9, and I get x is equal to 1. But I started with x is equal to 0.9 repeated. So they are the same number. Now, I'm not going to say that from now on, when you're writing a physics test, if the answer is 3, don't write 2.9 repeated. You might annoy your teacher. Technically, it would be right, but you might run into problems writing that down. But technically, if two numbers are different, there's always a number in between them. And there's no number in between 0.9 repeated and 1. So they have to be the same number.